Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? All right. What's up, Reki? What's up, Darsh? One sec. I really want YouTube Shorts to work right now. I had to uninstall Stream Elements Live because it was just messing up. And I was like, I can't have that. All right, one sec. Where's my output settings? I need to get my key here. Copy, paste, save, cool. Okay. Why are we not outputting? Let's try it again. Try it again. There we go. Come on. Come on. Ooh, bingo. Ooh. Says we have a connection now. We may be good. It says we're live, but I don't see anything. Ah, there we go.
Good job.
I got it to work. I think I did. One sec. I need to get... I think I need to figure this out. Okay, there we go. Video equals this one. Yeah, I'll figure this out. There's always like something. Yeah, dude, what? I gave it to you. Yeah? Oh my god. Alright. Stop. It is most definitely. Okay, one sec. Ninja Social Stream Ninja. That's what it's called. I think we are live on YouTube. Can one of you guys check for me if we're live on YouTube? I'm pretty sure we are. Oh god, now it's like super messing up. Let me remove this source. Yep. There we go. Okay. Test. Test. Yeah, nice. Okay, cool. Got it. Wow. God is alive and well. Okay, nice. Okay, cool. I trust that. Let's get TikTok going. Great. And then Discord's coming in right away. 1 second, everybody. There you go, Reki. Thank you for checking that for me. Appreciate that. Office hours. Good. Start the event. Yes. Pop this girl out. Make it that way. And then we just need to cast this one. One sec. Full screen projector. That one, 1080. And then there we go. Sharing screen. What's up, Monkey Boy 74? What's up, home slice, home slizzle? There you go. Okay, cool. We got everything working. Very happy. Nice.
That's dope.
Today was my second day ever teaching at UCLA. It was actually quite fun. I think I can actually probably find a recording of it. One sec. Also, let me set a timer because TikTok's going to get mad at me and ask me to fill out a CAPTCHA in 58 minutes. Okay, there we go. All right, that's good. What up, Shane Tricks? All right, one second. If I go to like Bruin Learn, I think Bruin Learn has it. I like log in. Then it needs my. Are you logging in on this thing? Yes. Let's see. Let's see if we can see Dr. Gold streaming today, or not streaming today, teaching today. This was my class. This is my nice little syllabus. You guys like my syllabus? Got a cute little picture of me, a little description. Tell the kids what's up. If we go to media. Oh, they still only have my first lecture up. That's annoying. This one doesn't have any photo from LinkedIn. It is the same photo, but yeah. If you want to see, this is the recording of me. This doesn't have any audio because they just gave me the microphone today, but this is me lecturing up in front of like 180 people. I guess the class before me, someone drew a pig on the whiteboard, chalkboard, but I don't really use a chalkboard. I use more of a kind of what I do with you guys. I use a digital whiteboard to explain things. So they have someone in the AV department who zooms in on me, on my screen, basically, that all the kids see. And then I guess we'll sometimes zoom out on myself talking, but not really. It doesn't look like that. Wearing a gold blazer, so iconic. Yeah, this is me. Yeah. Actually, I got this shirt at Buffalo Exchange for, I want to say, $15.
My man.
It was really cheap. It's actually a really cool shirt I got. I was a fan of it. Anyways, yeah, so today was the second day of class. Some of the kids found my stream, apparently. They said, oh, do you stream on Twitch? You know, are you Actual Education? Like, I found your TikToks. I was like, oh, okay. Yeah. It's the internet. I know people are going to find me at this point. Why is there a pig on my whiteboard? I know, seriously, right? And then, yeah, I did some cool questions. I'll maybe go through them with you guys later because they were good. They involved, I'm doing kind of a basic catch up on everything algebra and math related that you need in order to start learning physics for this first week. Also, because I got kids coming in and out, they're dropping or whatever, switching classes. So really the dust has to settle after the first week. And then the second week, that's when I'm going to really start going hardcore into physics. Did you do something to your students on April Fool's? I didn't, because I taught on the 31st and today, which was April 2nd. So Monday, Wednesday, Friday. What's up, Monkey Boy? Is that Justin? Or is that, who used to also be Monkey Boy? Well, Taco Cat used to be Monkey Boy or something. Anyways, wow, thanks. Sam, how'd your test go in, math? Oh, it's tomorrow. Cool. You got some more questions for me to go through? I can teach you. For free. That's the whole point of the stream, right? Not really. Okay. You're all good? You're gonna pass? Flying colors? I had, it's interesting. I had a kid that I was tutoring. Nice. Good job. I had a kid, who got accepted to USC, but he got accepted for 2026. So it's very interesting. It's like a conditional acceptance. So they said, yes, you can come to USC, but you have to maintain a 3.5 GPA taking college coursework coursework somewhere else. I've never seen this before. I know it's like it's an assumed thing, you know, go to community college, get good grades, and then usually they let you in when you apply the next year. But this was like a conditional contract. It's the same for Loyola. Oh, interesting. Yeah, I didn't know they were doing these. So we used to do a similar thing at University of Texas, where you would have to go to like one of the other campuses, like one of the other satellite campuses, and those would, if you did that for a year, you're allowed to transfer in. But I don't know how that works in the UC system. Not about, 90 a year. Fuck that, dude.
You done messed up, AA Ron.
Yeah, especially to be like, what? A mile away from your house or apartment or wherever you live like very close to LMU. There's no point. Absolutely no point. So it's an so what it is, it's a program where you go to college at like a sister campus. So for instance, in California, there's a bunch of what we call the University of California sites. So you have UCLA, that's the one that I teach at. Then you have UC Berkeley, which is in San Francisco. You have UCSD, San Diego, and then you got UCI, Irvine, UC Merced, UCSB, Santa Barbara, UC Santa Cruz. And there is kind of like a hierarchy to them. Like obviously Berkeley and UCLA are the hardest ones to get into. So I guess sometimes they let you go to one of the not so hard ones, and if you do well there, they let you transfer in for the other one as well. So pretty cool. Let me make sure the TikTok chat is working. Anyways, oh, I have two objects of the same shape. There you go. Whatever. All right. Nice. Okay. Yes. Okay, that's all working great. Cool. Okay, we got a couple questions today, so let me help you guys out with that, and maybe I'll go through part of my lecture as well to, teach you guys the same things I'm teaching, the college students in class. It's useful. It's math, and it's kind of funny. So, all right, let's start off the stream. Welcome to Office Hours. My name's Dr. Gold.
That's dope.
This is Actual Education, stream that helps you out with math, homework, science, homework. All sorts of fun education we're going to be doing today. If Skeeg comes by, I will help out Skeeg with his question. That was a good one. I remember I was kind of burnt out yesterday. I couldn't do, what's up, Kevin? How you doing? He was asking for, like, conditional this stuff. Let me show you what it was. And then Chantrix, I'll do yours, because it's question 22, which I know is not going to be, like, too bad, I hope. So, Skeeg, if you show up, you got 100% off your midterm? Oh, you got 100% in the class. Hell yeah, dude. Nice, good job.
That's dope.
Good job, Kevin. Yeah, I love it when you guys are doing well in class. Yeah, please always come by and tell me what you're doing. I feel better about it. Congratulations again on your acceptance to LMU's transfer pathway program at Santa Monica College. Oh, it was for 1 year after. Okay. Oh, so it is a formal program. Okay. Interesting they do that. You need 4 more classes to graduate. Oh, nice, Kevin. Well, let's help you get there, right? All right, cool. When Skeeg shows up, I will do this. This is cool. This is sequences and series, which is actually Zach's specialty. He does research on like how to teach this, which is really cool. Oh, fundamentals of digital design. That's cool. What degree are you going for, Kevin, again? Them series. Yeah, we'll see if Skeeg shows up. That was Skeeg's question from yesterday. Is he here? No, I don't see him yet. When Skeeg shows up, I'll do his. Okay, but we can start off with Chantrix's, which... Oh, man, here we go. This is another one of these counting questions. All right. If x and y are real numbers, the minimum possible value of the expression is... Ooh, and we got a screenshot coming in. It's okay. Who wants to bet that this screenshot is one of these Facebook soccer mom math questions? Is it? Damn it, you guys. Someone submitted another Facebook soccer mom question. I'll do this one later. Not the Facebook soccer mom question. I will do this one later. Dude, what? I'm kind of dude, where's the picture of like the, you know, questionable adult actress next to it who's like, oh, I deleted that page from last time. Okay. All right. Well, probably good. I did actually. Where was it? Was it here? No. What page was it on? Wasn't here. No, that was Sam. Oh, this, dude. Like, dude. This person doesn't teach math. Y'all with the fucking minion questions? Okay. All right, but let's do this one actually. This is okay. If x and y are real numbers, the minimum possible value of the expression is. Ooh, okay. Keck dub. They probably do actually. Okay. I'm gonna use calculus on this one, I think. Yeah, right? Yeah, let's use calculus. I like calculus. Calculus is great. That's also a very cool one. Thank King from TikTok chat. Oh, King has another cool one as well. Okay. This one doesn't look like as much of a Facebook soccer mom question. Okay, we'll do that next. This is a grade 12 question? Okay. I'm going to expand this out. Okay. So that's going to be, this squared is going to be x squared plus 6x plus 9. And then expanding this is going to be plus 2y squared minus 8y plus 8. I think that's what it is. Yeah, okay. Plus 4x squared. Man, this is really testing my brain power. Plus 49 times 4. Right? Is that right? Yeah. Yeah, 14 times 4. Okay, cool. And then plus y squared plus 8y plus 16. And this is equal to z, is what we would say, right? This is some value. And what we want to do is we want to maximize or minimize this. Okay. As a teacher, do you know do you sometimes pretend to not know something to see if students are paying attention? Not intentionally, but it definitely does happen. I just naturally, I will make mistakes. And then when that happens, someone actually did come up to my class actually on the first one. And she pointed out that I got something wrong. And I was like, oh, thank you.
Good job.
Yeah. Thank you. Is it minus? You are right. Thank you. See, exactly. Endar's paying attention. Right, Endar? You're paying attention, dude. Yeah. Yeah, it's not 4 times 14 is not 64. Sorry, that's 16 times 4, not 14 times 4. Yeah, okay. Okay, let's combine some like terms. I got all the x squareds here, right? So we got 5x squared. So those go away. Cool. And then I got, what was that? 50x. Cool. That's done. I'll do the constants at the end. 2y squared and y squared, so that's plus 3y squared. Cool. Minus 8y and 8y, that goes away. Nice. Minus 50x. Thank you, actually. Wow. Dude, everyone's paying so much attention. Good job. Good job, Reki. Here, actually, I owe you guys some saves, actually. Yeah, you get a save. And so does Endar. You all get saves. Okay. Okay, so we took care of the y squared. And now I have 8 and 16, which is 24. And I have 24 plus 9. Okay, so 9, 8, 16 is 33. Nice. I actually don't really care about this term. I'll show you why later. And then this is 33 plus, that's going to be 196. 4 times 49. Because that's basically 4 times 50 minus 4. And then when we add that, that's going to be 229. Okay, cool. All right, plus 229 equals 0. Yeah, this is actually pretty nice. So I need to minimize, or not equals 0, sorry, equals z. All right. The next thing to do here, so this is a 3D thing because the z coordinate is defined by x and y. So if we were to look at this in the planes of things, this would look like some sort of like surface where the z height, the height of it is dependent on the x and y. Complete the square. Not quite. What I'm going to do is I'm going to do partial z, partial x. And then I'm going to do partial z, partial y. And wherever these are equal to 0... Oh, actually, so Jeff is actually correct. This okay, so I'm using the vector cal solution for this, but Jeff is actually even better. He says because x and y are independent, like there's no xy terms, I can just minimize each part of these independently. So I can say, okay, what value of y is going to make this the least? Well, that's easy to see, right? Because even if y is negative, the squaring is going to make it positive. So I know y must be equal to 0. Yeah, you could have also... Yeah, Femvox is correct. You could have also just done the partial straight here and done the chain rule. That's also completely valid. Okay. So then all we have to minimize is this, right? 5x squared minus 60 minus 50x equal to 0. Well, this is easy. I can just pull a 5x out, right? Okay, so this is 5x. X minus 10 equal to 0, right? So this is going to have x-intercepts at 0 and 10, right? So that means, and since this is a positive x squared, that means it's a smiley face quadratic. So this would have to be 5. So, okay. So y equals 0, x equals 5 is what I get. So my constant term is the max. No, not quite. It's this, and then whatever the vertex of this is. Yeah. So 229, and then what we do is we're just going to plug 5 into here. So that's going to get me 25 times negative 5, which gives me negative 125. So negative 125 plus 229 is that 104? But you made that equal to 0. Oh. Can make it negative in that form. Oh. Oh, you're right. Sorry. Well, okay. Can make it negative in that form? What are you guys talking about? Make it negative. You want the min... Oh. Yeah. Well, the min is where x equals 5. Correct? Right? Because when I solved for x equals 0, x equals 10, that gave me the zeros, and then the vertex is always is halfway in between the two x-intercepts. So if I just plug 5 in, I should be okay, right? That's negative 125. My curious thing is I then get like 104. Oh, 104 is correct? Oh, cool, nice. Okay, yeah, actually, oh, that is right. Okay, cool. Nice, good job. Yay.
That's dope.
All right. That one new, it is, yeah. Although maybe I have to remove it now because people hate Elon so much. I mean, like, I agree, Elon's kind of a cock, but, you know. At the time when I added that, it was more funny that, like, he was doing this. Now it's kind of like, I don't know. I have a funny story with Elon Musk. I took shots with Elon Musk once. at a party. It was a SpaceX party. Who am I giving this to? Shantrix. That one was too easy. Yeah, don't hit me with number 25. Please don't.
You done messed up, Aaron!
Don't do that to me, please. Okay, cool. All right, nice. Good job. Good question there. That's dope. Let's try to see some of the funny math ones that have been asked. I think this one's actually probably pretty fun. Okay, let's see. A plus B plus C is equal to 4. A squared plus B squared plus C squared is equal to 10. A cubed plus B cubed plus C cubed is equal to 22. What's up? Good to see you, boss.
My man!
Mr. President, another question twice. Yeah. Yeah, Shantrix. Yeah, as long as the solution isn't ridiculous, you can post it. So, for instance, this was what, for 22? They actually made this a lot harder than I think it needed to be. We didn't have to do this much work, really. I don't know. Well, I guess their explanation's a little long. But, like, this might be a lot. 24 actually might be fair then. 24 isn't that crazy. But 25, yeah, bro. Do you see how this is the solution for question 25? It's all of this. This I'm not doing on a stream. I have limits. Oh, they gave multiple approaches. Oh, or yeah, maybe on the other one, yeah. But on 25, dude, that's crazy. Oh, this is solution 2. Oh, thank you. Thank you, guys, yeah. Yeah, right? So, yeah, okay. Right, if the solution is this, if it's a couple lines, I can do this on a stream. That's totally cool. If the solution is this, however, I'm not doing this on a stream. It's just too much. Okay. Let's go see the funny math here, though. This is actually kind of fun. All right. So my instinct when I see this, actually I don't really know what my instinct is here. A plus B plus C equals that. A squared plus B squared plus C squared is equal to that. I'm tempted to look at this as like a distance formula, honestly. Almost, right? Kind of think like, well, this, you know, if this was like delta x squared plus delta y squared plus delta z squared, that would equal to like some distance squared. And then is there a way for me to relate this as like maybe a triangle or something? But then I get lost at the cubes and the fourths. My other inclination is to maybe think about squaring this. So doing this. And then seeing what terms we get out of here. So if I do this, I'm going to get a squared plus b squared plus c squared. And then I'm going to get a lot of horrid cross terms. What are these cross terms again? Is this going to be 2ab plus 2bc plus 2ac? Is that correct? Is that what happens if I have a trinomial that's squared? I wonder if there's an equation for that. It's the multinomial theorem. Okay. Oh, that's cool. Ooh, there's factorials involved. Okay. So let me do trinomial squared formula. I just want to see what it is. Oh, it is. Okay, cool. Yeah, it is 2bc plus 2bd plus 2cd. Luckily, there are no, like, coefficients in front of it, so we're okay. Okay, cool. All right, well, once I've squared this, right, I know that a squared plus b squared plus c squared, which is here, this is all equal to 10. You could probably replace the a to the 4th with a squared. Maybe. Well, let's think about that. And the same with B and C. Yeah, well, let's see. So this is equal to 10. So that tells me that when I move that over, I'm going to get 6. And then I'm going to divide everything by 2. Okay. So that tells me that AB plus BC plus AC is equal to 8 minus 5, which is 3. Okay. I think this is useful. I think this will come in handy later. Maybe we need the cube stuff or something else somehow. I don't want to deal with like a squareds and b squareds and c squares as cross terms. But we could do this. We could write a to the 4th is equal to a squared times a squared. So in that case, a squared plus b squared plus c squared is equal to what? I don't think anything factors out of this really nicely. When in doubt, ChatGPT it out. Let me see if ChatGPT has like an inspiration for me for like what to do with this. I'm just curious. Yeah, Cuber, you do have to ask a question. Oh, there's already a solution for it? Let's see. Okay, let's see. How do they do it? Okay. Right, so we got to this. We got to the a plus b plus c is equal to 3. Identify the sum of cubes. Oh. Oh. Okay. And then do the sum of 4th powers? Oh, man. You got ABC equals -2 as well. So wait, how did they do this, sorry? So they did, yeah, what is it for sum of, whoa. It's sum of cubes with trinomials. Oh, wow. Oh, wow. See, yeah, I don't know these. But okay. That's kind of cool. So then, yeah, cool. You get ABC is equal to that because you know what AB, you know this right here is the negative of AB plus BC plus CA. Okay, cool. And then you use it for the 4th powers. And we're looking to figure out this. So just look at what I wrote above and do it for cubes. Yes. Yeah, no, I get what you're saying. Yeah, and that's what happens here. So here. So you can say, for instance, that Right. It's interesting that it's not a plus b cubed, though, right? It's this. I don't know where this formula comes from. Is this the multinomial theorem you guys are talking about? Sum of cubes with 3 terms. Yeah. Where did this come from, though? Where's this equation come from? The general form for the sum of 3 cubes is this. I didn't know that. That's kind of an obscure one, honestly, to know. But, okay. The nice thing here is that you know that this whole thing here is 22. We know that this right here is 4 from this. And then we know this whole thing here is 10. And then we know this is the same thing as minus AB plus BC plus AC. And this whole thing is equal to 3. Mathematica cheating confirms this, yeah. Okay. So then you can solve for ABC. That's not too hard. And what did we get? We got ABC is equal to -2. Cool. ABC equals -2. I agree with that. Okay, now I need another identity, which, I don't know. I don't know where these come from, but handy to know. So, we're looking for this. We're trying to get this. The nice thing is I already know what a squared plus b squared plus c squared is, right? This whole thing here is equal to 10. So this is 10 squared. Right? Okay. This is interesting, though. What's going to happen here? Because I see, like, my AB plus BC plus AC. So, if I were to square this, then I would get I would get a squared b squared plus b squared c squared. Sorry, let me just write that out. Sorry. So if we do AB plus BC plus AC, and we square that, we're going to get a squared b squared plus b squared c squared plus a squared c squared. And then you have all the cross terms, right? So then that's plus 2 ABC times b plus 2 ABC times a. And then plus 2 ABC times C. Oh, very cool. Yeah. And then look at this. This is super dope. Wow.
That's dope.
This is the same in everything, right? So now you have plus 2ABC, and now it's A plus B plus C. Or really, it's B plus A plus C, but whatever. Oh, fucking cool. That's so cool. And that whole thing is equal to 9. Okay, so this is 9. This right here was -2. And then A plus B plus C was 4. Okay, very cool. So then this was 9 plus 16, right? 2 times 2 times 4 is 16, but it's negative and you add it. Okay, cool. So then this whole thing here is equal to 25. Okay, cool. So this is 25. So now I have 100 minus 50, which is equal to 50. Is that the answer? Fembox says 50 as well. I agree with this. And then let's check. Answer's 50. Wow, that's super cool. Very cool question. I like that. That's fun. Facebook soccer mom question cooked. Yeah. I know. I think that was actually like a cool question because it taught me some things. Like first of all, I didn't know anything really higher than the sum of square. Well, okay, I didn't really know sum of squares first of all for 3 terms, but this kind of showed it to me. And then I didn't know we also have a sum of cube for 3 terms. Do you do material science? I can try. That seems a little specific. That would be my only hesitation, is that like, even though I do have a degree in physics, once you start getting into kind of the higher engineering classes, they tend to be more niche. Like, I don't know what the torsion of graphene is. I'm sure I could look it up, but they start getting really specific about things. But you can try submitting a question. I'm down to look at it. Yeah, material science is probably... Oh, thanks, Pen. Pen just said I'm the best. Okay, cool. That was a fun question. Let's go do one of the other students' questions. Let's see what we got. A doll heat layer TikTok. Oh, that's a fun one that you put on as well. Nice. I like that question. If you're still around, doll hair, just say hi in the chat, and I'll do your question next. But let me help out one of our students who's waiting around, which is going to be Reki. Let's do Reki. Yeah, let's help you out, Reki. But yeah, it must be otherwise. If you want to submit a question, you can just do it here. You can submit it to our website, and we'll go through it. Or I'll take an attempt at looking at it, and then I'll maybe throw it through ChatGPT and try to decipher it for you. I'm pretty good at reverse engineering things. Okay. Solve this. Okay. This is gross. I don't like all the decimals. You're right, the 4.9 is g over 2. Yeah. This does happen a lot whenever you have like 1/2 AT squared. And this is 9.8. You do get 4.9. Nice. I think I got your screenshot already. Or Descend d'Enfants. Oh, Descend d'Enfants sent one. The Lipschitz. Oh, what are we doing? Lipschitz continuous set? Oh my god. You're hurting me. Okay. Let me keep going through this one real quick, though. Okay, so I don't really like decimals. So what I'm going to do, and I notice everything only has 1 decimal place. So I'm just going to multiply the whole side by 10. So I'm going to take this whole equation and just multiply by 10. Because I can. 10 times 0 is just 0. But everything else is going to move the decimal place over 1. Okay? And I'm going to rearrange it so that it's highest power to lowest power. Oh, nice. Okay. I see it otherwise. I see that. Ooh, it's a figure. Oh, that's super cool. All right, I'll take a look at it. 49x squared minus 56x plus 16 is equal to 0. Yeah, you're right, Jeff. It is harder. I'm trying to think if there's an easy way to do this, because I like this. This is like a square of something, right? And this is like a square, and this is like a square. Like we got some nice squares going on. Well, this isn't. This is 7 times 8. Damn. I mean, you could always do this with the quadratic formula. It's just messy. I'm going to try just focusing on these. Exactly, Jeff. Yeah. I was going to focus on these two and just pull a 7 out. I'm just going to pull a 7 out. So this is 7x squared minus 8x. Okay, and then we have plus 16 is equal to 0. Finding the discriminant is like doing L'Hopital's rule. We love L'Hopital's rule. The issue, Jeff, is I technically need to pull out... I need to pull out another 7 here in order to do completing the square. Right? I technically need to do this. It's unfortunate. But, you know. Perfect square trinomial. Yeah. So I'm going to actually pull the full 49 out. But when I divide this by 49, that's the same thing as 8 over 7. Okay. Oh. FemVox does have some good suggestions. So what I'm going to do here is divide by 2 and then square. And so that's going to give me plus 8 over 7. Sorry, plus 4 over 7 squared. And then we're going to say minus 4 over 7 squared. Okay. This whole thing here can then be written as a perfect square trinomial, which is going to be x minus 4 over 7 squared. And then we need to still multiply this inside of this. So that's going to be minus 49 times 16 over 49. Oh, this is actually kind of nice. Right? Okay, cool. Plus 16 equals 0. Okay. So this is going to cancel. And then I got minus 16 plus 16. That's going to cancel as well. Wow. Goodbye. Oh, this is super easy now. Okay, nice. Okay, so now we get 49 x minus 4 sevenths squared is equal to 0. You can kill off the 0 as well. Goodbye. Square root of 0 is just 0. So you get x is just equal to 4 sevenths. Wow. That's actually kind of cool. Let's double check that though. I want to double check that. Where's my calculator? Why does my calculator keep disappearing? There we go. Yeah, is that how you were supposed to do it, Reki? That's actually a really cool question. Oh, really, Endar? That's what it comes out to? It's not. Why is it not? Descendant fonts. Why is it not? Why am I not allowed to multiply 3 by 10? 10 times 0 is still just 0, right? Is that cool? Not Discord. Where's my calculator? It's not the same function. True. So if I were to graph this, let me just show you how I would do it if I graph it. So I could do 1.6 minus 5.6x plus 4.9 x squared. Give it a good old graph-a-roosies. And then, ooh, yeah, you can see that because it has one solution, that's because the vertex is literally right here. I'm about to just zoom in right here. It's going to hit the x-axis at exactly 1 point. That's really cool. So I can calculate the 0. Left bounds over here. Right bounds over here. And that gets me 0.57142. What's up, Reki? I will send a screenshot. Just give me a second. I just want to make sure this is correct. And is that what 4 over 7 is? We could do the quadratic formula. I just didn't want to do it because it was ugly. Okay, nice. Yeah, that comes out to be it. Yeah, that works out. Yeah. It's an approximation of 4 over 7. It's an approximation, he says. Yes, this is equals to 4 over 7. Yes, congratulations. Good job. Yeah, there is a little bit of a line. Let me do a doll hair first. They asked on TikTok. Yeah, we asked it. And then who's next on the list there? And then Adarsh, I'll do yours. And then I want to help out engineering person. And then I got Descendum Fonts, and then I got Kevin. Yeah. Got a couple people we got on the line. Okay. This comes from TikTok, this question. Cool one. It says, if x is the average of m and 9, and y is the average of 2m and 15, and z is the average of 3m and 18, what is the average of x, y, and z in terms of m? Okay. My gut reaction here is to just write out the expressions for, like, what this means algebraically. So if x is equal to the average of m and 9, that means that m plus 9 over 2 is equal to x. And then y is the average of 2m and 15. You would write like this. Again, add the two numbers, divide by 2. And then z is the average of 3m and 18. And that's all over 2. Okay, so now we want the average of all three of these things. So that's going to be x plus y plus z all over 3. Which is this plus this plus this all over 3. Nice thing is they all have the same denominator. We love that. That's great. So that's going to be m plus 9 plus 2m plus 15 plus 3m plus 18 all over 2. And then all over 3. But all over 3 just means that... Because really it's all of this thing over 3. And so that's the same thing as times 1 over 3rd. So this is going to be divided by 6. Okay. So that's m, 2m, 3m. That's going to be 6m. And then we have 9, 15, 24. 24 plus 18 is 42. All over 6. Divide by 6. That gets me m plus 7. Choice B. Nice. That's a fun one. I hope that helped you out, Doll Hair. I think that was her name, Doll Hair. Doll Hair from TikTok. Where is my TikTok feed? There you go. Doll Hair. Okay. Oh, and then yeah. Sorry. Let me get the screenshot for Reki. Almost forgot about that. Sorry, Reki. Yeah, again, you could have done this one with the quadratic equation. You would have probably just made some approximations and rounding errors. And when I saw like 16, 56, 49, I know those are kind of nice numbers. And so completing the square keeps it in what's called exact form, because we haven't approximated anything as a decimal. I know everyone's always tempted to write these as decimals, but learn to just love the fractions. The fractions are great because you end up seeing some really cool shit. Like, stuff will start canceling out of nowhere. And it's awesome. So, yeah. There shouldn't be an approximation since delta equals 0. Yeah, but there would be approximations with them starting to... If they started writing out decimal versions of this, yeah. Oh, you're saying that because of the discriminant's equal to 0? You're right. Actually, sorry. You are right. If we were... Well... If they wrote everything out on one line, yes. I just know even if they were doing the quadratic formula here, they would probably do b squared. They would write that down as a decimal, and they would calculate 4ac, write that as a decimal, and they would subtract the 2. And depending how they rounded it, it may not come out to be 0. So, you're right, but you are right, dissidents, that the discriminant should be 0, so they should have just get one answer. Okay. Who did I say I work with next? Adarsh. Yeah. I'd never divide 4 by 7. Yeah, but you know what? A lot of students would, because they really don't like fractions. Okay, Adarsh, what's up? Adarsh is here. Okay. Find the value. Okay, this is cool. Yeah, this is what I'm talking about. They tell you what quadrant it's in. That's useful. So they say sine is equal to negative 4 over 5. Find the value of cosine. All right, let's do it. So what I'm going to do is, I know I'm in quadrant 4, so I'm going to look over here, right? This is where my eyes are. I'm like, ooh, what's going on here? And I need some angle to happen where sine, which is equal to the opposite over hypotenuse, needs to be equal to negative 4/5. Okay. So, the opposite has to be negative, because hypotenuse can never be negative. So, we know this is going to be 5. And then the opposite is going to be negative 4, which I could just, like, write as this. -4. Okay. So knowing that, we now have a triangle. This is one of those special triangles. Remember, I tell you guys all the time, Pythagorean triples, right? This is the 3, 4, 5, 5, 12, 13. There's another one with like 24 that's like useful. I forget what it is, but anyways, if you know these two, and also the multiples of them work as well, you can instantly determine that this side right here should be 3. And even more so, it should be -3, really. The negative comes from it being on the left side of the y-axis. Okay, so now you got to find cosine. Cosine is equal to the adjacent over the hypotenuse. Well, the hypotenuse is the same. That's still 5. Oh, did I fuck up? I put this in the third quadrant. Oh, Jesus. Descendants, good. You caught me, dude. Oh, my God. Thank you, dude. Yeah, Darsh, you have to catch that, dude. But okay. That's right. Yeah. Okay, so sorry. This one's on the other side. Y'all should have stopped me right away. This is the fourth quadrant. Jesus Christ. I make mistakes sometimes, for sure. Also, I don't know if you can tell, but I'm definitely fighting something. I'm pretty sure. I don't know. I don't know if it's like allergies or whatever. I don't like feel sick, but my brain feels foggy. I don't like it. Okay. 2 days at UCLA and I'm dumb as toast. Yeah. Okay, my bad. This is -4. This is 5. So this is going to be +3. Yes, correct. Okay. So now when we do cosine, it's +3/5, right? Have I seen... Oh, T-Tau? Dude, one of my friends in grad school had him as an advisor, said he was an absolute, like, monster. Yeah, Terrence Tao. He's a cool guy. But anyways, yeah, so the answer here would be 3/5. If this was quadrant 3, like I was originally doing, then this would be -3/5. That's why they specify this at Darsh. Is you need to... Because sine can be negative in this quadrant and this quadrant. This is also the thing that y'all were talking about, right? All students take calculus. So the things that are positive, sine is only positive here and here, all and here. So sine is negative down here. Also, sine measures like the y component, which is below the x-axis. So yeah. Okay, cool. Good. Does that make sense to you, Adarsh? Yeah? You could then find any of the other trig functions. The other... Yeah, use that mnemonic. Okay, cool. Finding theta will be more useful for the future. 100%. If it isn't a nice triangle, use the Pythagorean theorem. You'll be fine. But your teachers are lazy. They're just going to use Pythagorean triples. So, nice. Cool. Great. Good job.
Well done! Well done!
All right, what's going on in the chat? All right, I'm going to go help out the next submission, which... Oh, wow. Name the... Dude, what? Okay. Must be otherwise. You're going to have to maybe, like, help me a little bit here. Okay. I'll try to help you, though. Because, yeah, this is a cooling curve. It's actually pretty cool. Name the microstructural products of the eutectoid iron carbon out. Do you see what I'm talking about, by the way? These are all very, very niche terms that I've never heard of. I've never heard of eutectoid. The hell is eutectoid? I don't know. We'll figure out what it means at some point. Points. No, eutectoid. Yeah, no you. 0.76 weight percent C. second. I don't really know what that means. That is first completely transformed to austenite and then cooled to room temperature at a rate of 200 centigrades per second. Figure 10.28 is the continuous cooling transformation diagram for a eutectoid steel on which it is superimposed two cooling curves of specified cooling rates. Okay. Okay, so let's look at what this axis is. So, I love how they got to do Fahrenheit and centigrade. This is so engineering. Like, we just won't let Fahrenheit die. Okay, also, this is logarithmic. Do you see how this is a logarithmic axis here? This is kind of cool. So, we're saying that, austenite to perlite. What does that mean? Are we saying that the dashed line is austenite, and then when it curls back up, it becomes perlite? But then what is this, like, martensite? What are these words? What are all these light words? Oh, man. Okay. Well, okay. I know the rate of it is 200 degrees centigrade per second, okay? If this is 35 and this is 140, my guess is that 200 is going to follow the trend and probably be this way, right? This is probably 200s. Would knowing the two answers help? Well, are there two answers? Oh, because it's the products. Sorry, there are three answers. Oh, the answer choices. Yeah, maybe. Yeah, you wanna type out the answer choices? It's interesting they say critical cooling rate. I wonder what that means. Usually it's critical means this is the limit that you can do things. So like there's a limit of how quickly you can cool this. Also, I'm gonna run this through ChatGPT. Just because I want to learn some stuff today. It does look like phase space. I agree it looks like phase space. But I just don't know what eutectoid means. I've never seen those words before. But I'm down to learn. Learning's fun. The answers are perlite only, martensite only, or both martensite or perlite. Cool. Okay. Let's let her rip. I'm gonna let a couple dolphins suffer from water being used to cool down GPUs that are currently making Studio and Ghibli AI images, but also now helping to let me understand material science. Of course, the answers had to be, well, the words at least are here. I see these things. So, I will say that my gut instinct must be otherwise, is that it's martensite, because it looks like the border between martensite and perlite is the 100 oh, 1 second, we gotta go make sure TikTok isn't kicking us off the platform. Because it looks like the border between martensite and perlite happens between 140 degrees and 35 degrees Celsius for cooling, right? Oh, actually, TikTok's not getting mad at me. Oh, nice. Love that. Okay, cool. Good job, TikTok. So 200 would be further on the left here, right? And then here, let's see. This is what ChatGPT said. ChatGPT said, okay, from the continuous cooling diagram for eutectoid steel, a cooling rate of 200 degrees centigrade is fast enough to miss the perlite forming region. It avoids the perlite nose. Okay. Is this the perlite nose right here? Consequently, the austenite will transform almost entirely to martensite upon reaching the MS temperature. Okay. Because this is the temperature of it. Right, wait, sorry. It's completely transformed to austenite and then cooled to room temperature. So cooling means the temperature is going to go down. So stuff has to go down this way, and that takes time. So it is going to do this. Perlite is crystalline. Martenite is non-crystalline. Exceeding critical cooling temperature rate generates non-crystalline stuff. That's what I got from ChatGPT. Okay. Yeah, let me have it like... Okay, let me, first of all, like, what is a eutectoid steel? Does that matter for this question? I'm going to learn some stuff with you, you know. So, a eutectoid steel is one that contains 0.76% by weight carbon. Okay. So, eutectoid is just a fancy word for this. Because steel is an alloy, which means it's a mix between iron and carbon. Oh, yeah, the key to upload stuff. Yeah, cool. That's this. Submit. In the context of the problem, the fact that steel is eutectoid matters because it tells us that under normal, slower cooling rates, the transformation would be perlite. However, the cooling very rapidly, steel doesn't spend enough time in the temperature range where perlite can form. Instead, the austenite bypasses the perlite formation, often depicted as the nose of the triple T diagram, and transforms into martensite upon reaching the MS temperature. M start. Okay, cool. Let me see. What is the difference between martensite and perlite? I'm just gonna burn through all my ChatGPT credits today. Okay, this is some additional information that he's provided for us. Okay. I mean, this is fun. We're going to learn material sciences today. Lifelong learners we are. Okay, here we go. Eutectic phase is one of the phases found in the eutectic structure. Eutectoid reaction, a reaction in which, upon cooling, one solid phase transforms isothermally and reversibly into two new solid phases that are intermittent. Okay. So isothermally means at the same temperature. We know this from thermo. So this is delta T is equal to 0. Reversibly, I believe means that delta S is equal to 0, maybe? I forget what reversible means, that it can go backwards and forwards. And the two solid phases, I'm guessing, is the perlite and the martenite. Where the martenite is a crystalline structure, and I believe the perlite is not. Let me see. So here's some more information we got. So here we go. Martensite occurs during rapid cooling when the austenite... Dude, where are they getting these... Dude, what is austenite? What are these funny terms for things? Oh, sensation. I have to change the ticker for you. You didn't. Yeah. Don't worry. Okay, there you go. All this is required for a freshman class. I'm sorry. Well, where are you going to college, man? It's pretty advanced if you're already doing this for a freshman. Vanderbilt. Ooh, cool. That's good school. They got a good basketball team, I think, right? Good basketball team. UCLA. Yeah, do you imagine if he was going to UCLA? Like, I'm the physics teacher. Okay, here we go. Austenite is a high temperature phase of iron. Okay, so this is the iron that's very hot, and that it's called austenite. And we're cooling it down. Okay. It can dissolve more carbon compared to phases like ferrite. Okay, cool. This is all, I don't know. To me, metallurgy, I feel like we're back in the 1400s or something, like figuring things out. But I think this is the main concept here, right? Martensite forms when you have rapid cooling. Perlite forms when you have slower cooling, where the carbon atoms have time to diffuse. Oh, okay. A diffusion. So diffuse means like to mix into other things. And here they're saying like it's a shear. Shearing is when you have things like going, like splitting on each other. Right. Typically very hard, but can be brittle because the rapid okay. In a stress lattice. Oh, this is cool. You think the next graph will really help? Okay. The continuous cooling transformation diagram? I think you sent the same graph twice. Is it this one? Oh. Oh, same graph with caption. One sec. What's up, Kent?
Good job.
You know, maybe Omega Kent actually knows about this stuff, honestly. Yeah, it's material sciences. Okay, isothermal heat treatments are not the most practical to conduct because an alloy must be rapidly cooled to and maintained at an elevated temperature from a higher temperature above the eutectoid. Most heat treatments for steel involve continuous cooling. Okay. Yeah, constant temperature. But how does this stuff stay at constant temperature? Figure 10.27? I don't see a figure 10.27. Can you upload it again? I just don't see it. I see the same thing twice. I understand that, like, I want this. Or sorry, is this figure 10.27? You just re-uploaded it. Okay. This is what I'm getting as the most recent thing you uploaded. Unless my thing is bugged. My thing could be bugged, but I hope it isn't. Yeah, I got this one again. Here. No, but they are unique. I'm getting unique PNGs here. I'll show you in the Discord like what it keeps showing as being sent. So I saw this one. I saw this one. But then this seems to be the same image 3 times. Unless my code has broken, but it's been working for a while, so I'm confused if it's broken. Because it's called image 174364265.png, right? Followage. Does that work? Yeah. Here. Tell me if this is the name of the right PNG. There we go. There we go. Okay, this is different. 4 times the charm. Yeah, good job. Good job. Yeah, okay. Okay, let's see. Ah, see? This looks very, very similar to what your homework question was. Okay. So it says moderate and rapid cooling. Okay. Normally, bainite. Dude, what the hell is bainite? Dude, all these ites. Just below the nose. Indicated by curve AB. Where's this curve AB? Sorry, where's AB? I don't see it. Okay. This is the key thing here. So it says, for the continuous cooling of a steel alloy, there exists a critical quenching rate, which is the minimum rate of quenching that produces a martensitic structure. Yes, exactly. And I agree. Endar, yeah, I agree with that. Yes. That's what it's saying. So on these cooling curves, this is 140. This is 35. And if you are greater than 140, then you will have a totally martensitic. If you are less than 35, you will have a totally perlicitic, I guess, or perlite, whatever. And then if you are in between the two, you'll have a mixture. I don't know what they're talking about. Misses the nose. What is the nose? And also, what is this? What's happening here? I understand these. I'm cool with these. But then they're just like austenite, perlite. Like, what? Oh, man. Let me ask this. What is the nose? Is it where it turns into a solid line? Yeah, why are they calling it a nose, though? It doesn't look like a nose to me. Okay. All right. I think we understand this. Must be otherwise. If it's this way, it's this. If it's this, if it's this. If it's in between, it's this. Oh, yeah. Oh, yeah. I would have told you to try martensite. Oh, that was correct? Nice. Good job. Yeah.
Well done! Well done!
If you want, the next graph just gave me a seizure. Yeah, I bet. Yeah. I think ChatGPT does a good job at like learning this stuff. But I don't really understand the underlying processes of things, but I'm able to like decompose what the graph is trying to say. So hope that was helpful. I'm not gonna ask for your help. You should see this monstrosity. Show it to me, dude. I love like, what do they call it? Like lost porn? Like just show me like rage questions. Okay, and then let's work with dissonance. Dissonance, you're going to teach me some set theory because I have no clue what's going on here. Oh, wow. Oh, this is a big image, dude. What? Excuse me? Dude, what? You poor soul, dude. Dude, what the fuck is this, dog? What? This is a... Dude, what? What's happening? Oh, ooh. They talk about the nose. Do you see how they say the nose? This is the nose, Endar. Look at this. This is the nose, apparently. So I think these are noses. I think they call these things noses. Because it's like... This is the nose, apparently. Oh my god. Nice nose, bro.
That is
The
one
nose,
big pile of shit.
That's one big pile of shit, dude. Yeah. Yeah. Must be otherwise. Do you have TAs? You must have TAs, or your professor must have office hours, right? That's actually what I model this stream after I model it after what like office hours should be for like college. But there are people that actually have degrees in this stuff and know about this and would probably be better at talking about it than I am. I'm happy to do it on a stream here, but your best resource is probably a TA or a professor who actually does material science. I enjoyed your question though. It was fun. I got to learn some stuff. Our TA is a graduate student who is graduating material science, but on a macro level. Like, exclusively all concrete rebar? Okay, so this is a funny concept that happens. And you're not alone in this. Must be otherwise. So what happens in college, especially with graduate students, is that graduate students go to grad school to take courses to do research and study very hyper-focused, specific niche topics. So, oh, you're going to be a TA in 2 years? Yes. Exactly. So, in doing this, in focusing on these very specific things, which in your case is your TA focusing exclusively on all concrete rebar, they forget how to do the earlier basic stuff beforehand. It happens also. I mean, I tutor kids privately on the side to pay my rent and stuff. And I work with kids who are, for instance, taking vector calculus, or they're taking partial differential equations, and their TAs are often, I don't know, non-Euclidean topological geometry land. And because they're so far down the rabbit hole of what they're studying, which is very specific, they forgot how to do the quote-unquote basic stuff that they should have known they should be able to do, because they had to do it to get that far in grad school. But they become so focused that they don't know the stuff before. But yeah, descendant fonts is correct. In most cases, once they see it again, they will recognize the idea. They should, because they've done it. They had to. Your TA, who is studying all concrete rebar, had to do this stuff at one point, so they can remember it. So that's also kind of fucked up. If he said he can't help, then what's his job? You imagine if, like, I don't know, someone asked me to make burgers at In-N-Out, and I said, well, I can't make burgers. Can't help you, dog. I wouldn't have a job. If he can't help, he's lying. 100%. I just think he can't be bothered to be honest. Oh, well, yeah. Well, your professor should be able to do it. If he's teaching it, at least. I don't know. You know, I have sympathy for the grad student, because he's also probably just trying to get his degree, and this TAing is a stipulation as a part of his, like, contract in order to not pay tuition at Vanderbilt, and in order to get his PhD, he has to provide labor, which is basically cheap slave labor in the form of being a TA. And so he probably doesn't want to do this. He doesn't want to be a teacher, but he's forced to. So I understand why he's probably being dismissive. Don't get me started on my professor. Yeah. Right, exactly. And there's a lot of pressure for him to publish stuff in all concrete rebar. He probably has a qualifying exam, or he probably has an oral exam. Yeah. And yeah, your professor also probably does not want to teach this. Yeah, Endar, please. Yeah, post whatever link. You should be able to post links. I think you can. If you can't, just... Okay, nice. Okay, we're going to go watch this. But as just a little side tangent, must be otherwise, especially in your intro freshman courses, your professors don't actually want to teach these courses. They're being forced to, because it's part of their, like, job description. In reality, they're at the university because they're getting research money to do their own little thing. Exactly. And yeah, he hasn't taught undergraduates in a decade, right? Because he has tenure, probably, right? This is the hilarious thing, and this is directly related to, like, what's happening in my life. So I'm teaching physics to undergraduates at UCLA, but I am not a tenured professor. I am, quote unquote, a lecturer, because I'm there on the basis of they need people to teach this course, and I like to teach, so I'm going to put some effort into teaching. Versus the tenured professors there that are being forced to teach it don't want to. And so they're not going to give a shit. And also, they don't need to give a shit because they're tenured. If they do a bad job teaching, no, university doesn't fucking care. And they can't do anything. I mean, eventually the kids get mad enough, and, like, this person has a terrible rating. And I would think, in life, do you really want to go around having a terrible student rating? Do you want, like, your legacy to be like, this guy fucking sucks, and, like, cause my life to be living hell? Like, anyways. Some professors teach certain stuff because they also want to learn. It's a good business for students to fail. Yeah, exactly. Yes, MK Animates. I can tutor you in ACT math. What you want to do, and yeah, Cuber, we'll work with you soon. 1 sec. Is submit a question. Here. Yeah, go. There's a link that you can use there to submit a screenshot, maybe of an ACT question that was difficult for you, and I can explain to you how to do it. That's the best way. Yeah, fuck the ACT. I agree too. Okay, let's go watch this video that Endar found for us real quick, and then Cuber, I'll work with you. Let me pull this up. Sorry, where is it? There we go. But first is let's guess what the advertisement is. Oh, it's taxes.
1099.
Yeah, taxes are due.
Tax expert who helped.
Yeah, and they know me. Okay. Okay, wow.
So this module we're going to now talk
Well, it's a 9-minute video, so I don't know if we're going to watch all 9 minutes.
similar to isothermal transformation diagrams.
Yeah.
All right. So
Martensite starts at 4. Oh, dude, these are the exact same diagrams. Nice. Okay, let's go forward. Let's go forward to the Martensite stuff. Okay, here we go.
So, like I said, in this one, what we call the plain carbon.
The plain carbon.
Where there's not many alloying elements, this reaction is relatively fast. You can see that the perlite reaction starts within a second, right? So very rapid. So
what does he talk about the perlite
for
reaction?
The different regions we can kind of denote with the different rates. So if we are above the blue curve here, we see that we form only perlite. So slower than this rate, we have all perlite, and it can
Cool.
of course fine depending on the relative rate.
I like that.
And this works out to be 35 degrees per second. So that's a rather rapid cool. In the middle here,
Wow, Mondo, thanks for the sub, dude. Appreciate you, big dog. An inspiring YouTube streamer too.
Perlite, but you'll notice it doesn't go through the green curve. It passes through this black curve, which means that it's incomplete. And so in that case, if it continues to cool, it's going to get down here to martensite and form martensite from the
Oh, okay. So this like bounces. Is that what we're saying? It bounces off that green light, that green curve.
We're going to have a mixture of martensite and perlite.
Uh-huh.
And then in this other range, denoted by the red, you see it just encounters this point right here.
Yeah.
Which is the start of perlite. So anything faster than let me go through this martensite one again. So in that range, we form perlite.
Okay.
Goes below about 220, and then this critical cooling rate.
This is a great video. Who dat? Hawk Tua. What's up, Who dat? Yeah.
The closest and
okay. See, this guy actually this guy teaches. I'm a fan of this guy. This seems like a great professor, you know? Oh, look, he even goes into your diagram here, by the way. Which I'm not going to go into this because this is too much. But anyways, this is cool. So yeah. And I think Endar brings in a very valid, great point here, which is even if your professor sucks because he doesn't want to teach, or your TA sucks because life is too stressful and they're paid like a slave, you always have YouTube. You have an infinite library at your hands that you can go learn things from people who actually give a shit about teaching about it. So, and I mean, you can also find people like me, but again, I'm not the most qualified because I don't do material science. I've never done material science. But hopefully, that link helps you to, for instance, this is what I would say. If you're not getting anything from the lecture that you're going to, stop. Like, stop going to that guy's lecture. And what you should be doing is going to this guy's YouTube and just watch his lectures. And those will give you more information and more understanding than sitting in the room with some crotchety old man who doesn't want to be there. Yeah. Anyways, I hope that helps you out. Okay, yeah, okay, Cuber, you gotta go in 20 minutes. Let me help you real quick, and then we'll do Disinfons. Yeah, you're very welcome, dude. Yeah. And I mean, come on the stream whenever, you know. We always like to hang out and chill. Disinfons says, how much math have you done in grad as a physics student? I didn't do any math in grad school. None. I mean, all my classes required math, for sure. I did a lot of linear algebra and quantum mechanics. And then I did a lot of, I want to say, PDEs in electro and in plasma. But I didn't explicitly take any math courses as a grad student. My undergrad math topped out at probably around, I want to say complex analysis. I did DiffyQ. I did vector. And, yeah. And then complex. Oh, and linear algebra. I did that too. Okay. Cuber's question is, what are quadratic functions? How do I make them? Graph and solve. I'm clueless, not gonna lie. Okay. Okay, Cuber. I mean, that's cool. Quadratic functions, yeah. All right. I'll give you a little rundown of things. So, quadratic functions are functions that are of this form. ax squared plus bx plus c is equal to, well, quadratic equations is when this is equal to 0. An equation is when it's going to be equal to something. Usually what we talk about is like a quadratic function, which is y is equal to ax squared plus bx plus c. Cuber says quadratic is anything just curved, ain't it? Well, not quite. Quadratic is a special type of curve. It means that the highest exponent you see in this stuff is 2. Okay? No, I haven't done any of the other funny ones yet. I will do them, though. Yeah, this is called quadratic because it goes up to... I know quad kind of makes you think 4, but for whatever reason, it's 2. You could also have this, ax cubed plus bx squared plus cx plus d. This is a cubic function. So just as your username, right? The cuber is cool. This is a cubic function because it goes up to the power of 3. And then you can get quartic. Yes, always to the power of 2. Exactly. Yeah. If you have something like this, which is y is equal to ax plus b, do you see how... And first of all, if there's no exponent here, we assume this to be a 1. This is called a linear function because it makes lines. Oh, quadratic means parabola. Okay. What do the B and C stand for? Good. They stand for different numbers. Okay. These right here, Cuber, are called coefficients. And they are just going to be regular numbers. So, for instance, I could have something that looks like this. Let's say y is equal to 3x squared plus 2x plus 4. In this case, comparing ax squared plus bx plus c, you would say that a is equal to 3, b is equal to 2, c is equal to 4. These are called the coefficients because they're the numbers that are in front of the exponent stuff. Oh, you were calling this? Nice, cool. Yeah. You were absent when your teacher taught this? That's okay. Correct. Yeah. Yeah, if we want to get formal with it, yeah, I should technically say that y equals f of x. But for the sake of Cuber relearning it in high school, I don't want to like confuse people too much with things. So I just say y equals x. It's kind of a function. It's good enough for him. Yes, exactly. Yeah, but you are right, Omega. Omega, you are totally right. There is a difference between something passing the vertical line test being a function and not. Right, because if it was x of y, it wouldn't work out. Correct. What's the difference between a function and an equation? Good. A function, so for instance, f of x is equal to blah, 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 takes an input x and gives you an output f of x. That's what a function is. Functions take things. I like to think of like functions are like a microwave or something. Yeah, like you put stuff in, you put x in, and then f of x comes out, which is usually y. Usually, like, you put in x's and you get out y's. That's a function. It's like a relationship between two things. You could kind of think about it like at the gym, right? If I put 45-pound weights on and I lift, then I get muscles, you know? And if I put 90-pound weights on, I get more muscles. So you could think of this as like the weights. This is like working out. And then this is the muscles. Last time I put X in the microwave, things got heated. So f of x, where x is 4 degrees, is the same as like y equals 4x. I mean, close. I think what you're thinking about here is slope. So if you had f of x is equal to 4x, and you were to graph this, like f of x versus x, which is the same thing as y, usually, this would end up looking something like this, where this would be 1, for instance, and this would be 4, this would be 2, and then this would be 8. Yeah, we'll get into that. That's called transformations. But, for instance, if you plug 1 into this function, you get 4 times 1, which gets you 4. If you plug 2 into this function, you get 2 times 4, which is 8. So this is a relationship between x and f of x. And the slope here would not be 4 degrees. I don't know what it would be. Something. I have to do the arctangent of 4, but anyways. Yeah, you're talking about, like, how do I find out the function equation for the quadratic? Okay. Well, usually it's given to you. There's a difference for finding the quadratic equation. The quadratic equation is something that lets you solve quadratic functions that are equal to 0. That's the technical thing. So if I have, for instance, equations, C functions, cow plus grass equals hamburger. If you put 500 pounds in, you get a free bed underground for the rest of your life. You're 6 feet under, dude, Chantrix. Yeah, so if you have a quadratic function, so for instance, x squared plus 5x plus 6, right? You could solve this for when this is equal to 0. You could figure out what x values do that. And that would be using what's called a quadratic equation, which tells me that x is equal to, in this case, it's going to be negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6. I'll show you where this comes from, and then this is all over 2. Yeah, the quadratic equation, here, quadratic equation, is a fancy tool. My Algebra 2 teacher used to call this the big gun. He'd be like, it's the big gun. But it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where the a, b, and c, Cuber, are the same things as these. So a is the number in front of the x squared, b is the number in front of the x, and c is the number that doesn't have any x's next to it. And if you plug those in here, which is like what we've done here, you're going to end up figuring out what values of x cause this whole quadratic function to equal 0. In this case, this becomes negative 5 plus or minus the square root of 25 minus 24 all over 2. 25 minus 24 is the same thing as 1. Okay. So this is negative 5 plus or minus the square root of 1 all over 2. Square root of 1 is just 1. And so you get 2 solutions here. You get negative 5 plus 1, which is negative 4 divided by 2, Or you get negative 5 minus 1, which is negative 6 over 2. So that gives you the answers of negative 2 or negative 3. Omega Kent says, a function is kind of like a transformation. You take the argument, and according to the definition of the function, you transform it into another thing, while an equation just declares a relationship between its components. I like that. That's a good way to describe that. I'm surprised calculators don't have a quadratic formula button yet. The quadratic equation is continuous by inverse function theorem. This means that the eigenvalues are continuous. Descendant fonts, dude. You're choosing violence, man. But you're probably right. I'm actually curious, because I have been working a lot with eigenvalues and eigenfunctions. I'm teaching a student quantum mechanics, and they're doing a lot with eigenstates. So, Cuber says, seems simple, but that would be hard to remember on a test. Well, you can come up with a mnemonic for this if you want. But anyways, so the last thing I'll just leave you with before we move on, and I know you got to go soon, is once you've solved here that x could be negative 2 or 3, you can go check it over here. You can start plugging it in and see if it works. I'm missing the you know why tonight. If you plugged in negative 2, you get negative 2 squared plus 5 times negative 2 plus 6. Negative 2 squared is the same thing as 4. Negative 2 times 5 is negative 10, so you say 4 minus 10 plus 6. And look at that. 4 minus 10 is negative 6. Negative 6 plus 6 is equal to 0. And the same thing works for negative 3. Yeah, I think it's late for sensation. It's pretty late for sensation, and I don't know where Seth is, but it's okay. Anyways, okay, cool. Does that make some sense to you? We did like a pretty quick just crash course on quadratics. Okay, cool. Nice. Good job.
Well done! Well done!
Ooh, otherwise has a thing. Well, I'm going to do descend fonts first. And then I will do this. Dude, otherwise, what did you ask me here, dog? What is this? What's up, the new kid? What's up, dog? What's up, Big G? Okay. So, this is the other question I'm eventually going to do. Otherwise, I think I need to know what this is. I need to know what the Avrami equation is, if you can send that to me. I got a day off tomorrow because of teacher review day. All right, cool. Okay, descendant fonts. You have to walk me through this because I have no clue what this means. But it's a great question. Okay. Consider x prime is equal to f of x of 0 is equal to x naught. Okay. I'm cool with this. This is an initial condition, right? I understand that. And this is saying that x prime. So sorry, what is x prime then? So we're saying dx ds maybe, or dx dt is equal to f of x. Yeah, I have no clue what a Lipschitz continuous function is. Okay, thanks, Shantrix. I appreciate that. Yeah, alright, this will be for our next student we work with. Okay. Alright. Prove 1 is equivalent to 2. Okay. U is contained in all real numbers. The goal is to show that there exists a solution. Psi, negative a comma a, goes to Rn to the integral equation. Okay. So I'm saying that psi of t is equal to x naught plus the integral from 0 to t of f of psi s ds. Okay. Where does this come from? I mean, I started thinking about, is it called the fundamental theory of calculus? Where we say that, like, d dx, or what is it? Like, sorry. d dx from 0 to a of f of x dx is equal to f of a minus f of 0? Or is it just f of a? I think, is it just f of a? It is all Greek. Yeah, literally. Yeah, it is. Yeah. Is this, am I thinking correctly, guys? I think I am. Fundamental theorem. Yeah, I was right. Well, the one with the derivatives. Yeah, well, where is it? Where is it? Part 2. Is that my intuition? Yeah, I'm again, I don't know exactly all the set theory stuff you're talking about, but this looks to me like this. And also because you told me that the derivative is f of x. So this is the integral of a derivative, right? So this is the integral from 0 to t of so sorry, what is that? It's like d yeah, ddt, right? Oh, wait. F of psi of s is equal to psi of s dot, right? That's what this condition comes from, right? So this is d psi of s dt. Okay, which I can pull the ddt out, right? Uh-huh. Okay, and then if I pull this out, right? Now I literally just have the fundamental theorem of calculus, which says this is equal to psi of t. That's it, right? Psi of t times the derivative of this, which is dt dt, which is just 1. Which is just this, I think, right? Yeah. Did I just prove it? And then what? Oh, and x0 is 0. Or x of 0 is 0. I think I tried. I think I did a valiant effort on this one, but I see kind of where like the simpler calculus might apply to this. I don't know what Lipschitz continuous means. Actually, I want to look that up real quick. What is Lipschitz continuous? There exists a constant L greater than 0 called the Lipschitz constant such that for every pair of points x and y in the domain, the following equation inequality holds. So it means that like the difference between the points has to be bounded by some number. Uniformly continuous, but the converse is not true. Okay, cool. I see. It doesn't oscillate or change too abruptly. Oh, nice. Okay, so does that also mean the derivative is continuous? Because I understand it's a continuous function, but does that also imply that the derivative is continuous and that maybe all higher power orders of the derivative are also continuous? Let me see let me help this student out real quick. The Avrami equation, dependence of fraction on transformation of time. Yes, because it is in the space of C0. Okay. Distant D'Enfants, what's your background, man? You're a grad student in math, or you're just really smart undergrad at math? Because you seem to know a lot of math, which is cool. The parameter n is known to have a value of 1.7. If after 110 seconds the reaction is 50% complete, how long will it take for it to go to 98% completion? The reciprocal of the time... Dude, what? Dependence of fraction of transformation on time. There was... I think things that obey the Avrami... Oh, I see. I see. So this is saying that, like, what is this? Sorry, is this saying that, like, 0.50 is equal to 1 minus e to the negative k? And then this is 110. E to the negative 110 to the 1.7. Okay, that's annoying. And then they're saying, what is 0.98 equal to? Okay. Yo, your first year graduate student. Oh, that's very cool, man. I'm glad you're so interested in math. That's pretty cool. Do you know all our other math streamer friends, by the way? Have you talked to these guys? Have you talked to Penn Center and Zach, Eric? Obi's also a big math guy. Don likes math. Oh, of course, great. Okay, cool. Yeah, they're friends of ours. We like them. They know more math than me, but I'm slowly leveling up. Oh, thank you, Fembox. Yeah, appreciate that. Okay, negative 0.5 is equal to negative e to the negative k times 110 to the 1.7. So I'm gonna say solve for k. I do need to update that list. Who should I add to that list? Ooh, okay. One sec. Let me go find these people. Oh, TikTok died. I know TikTok just died. One sec. Because I just got the notice that we have 78 viewers, which we do not. That means that, like, I got some, like, hot tub stream that just hit. Okay, one sec. Let me go live again. Or actually, I'll just leave it for now. It's okay. Because we're gonna end the stream pretty soon here. Undergraduate, graduate stuff. Let me go check them out real quick. One sec. Twitch.tv/ the brim or the one where it bounces. Well, now they're being dirty with me, and they're not telling me when I have to do it. Okay, cool. Academy useless ideas.
Everything you know is wrong.
Everything you know is wrong. That's how he's starting off with. That's kind of funny. All right, I'll go find this guy too. I always like to see these people streaming, because it gives me more people to raid later. This is cool. Let me give him a follow as well.
With hotels and vacation rentals, Booking.com has something for everyone.
Looks like he does piano and fun stuff. Okay, cool. Let me do this real quick. So this is 1/2 is equal to e to the e to the negative k times e to the 110 to the 1.7. Can I multiply this? I can, right? I can just say this is equal to the 110 times 1.7, right? So I can say 1/2 times e to the 110 1.7, and there's a negative on there, right? Equals e to the negative k. Academy Useless Ideas is great. Cool. No, I'll check them out. I was checking out Fred today after during my office hours. I saw you, Fembox, there. Or no, I saw Zach there, sorry. I saw you, Femvox, on another channel, though. I did see you recently. Okay. Jesus, that's a very small number. Okay. Okay. Okay, so this is 3.06 times 10 to the negative 82. Equals e to the negative k. So take the ln of both sides. It's gonna be so big. Okay, cool. So you get that k is equal to 187.69. Yeah, it's all good. Right, let me move all this stuff down for you. Yeah, okay. So then this is equal to 1 minus e to the negative 187.69 times I think we're solving for t. So we're solving for t to the 1.7. So I'm gonna get 0.02 equals e to the negative 187.69 e to the 1.7t. Divide this over. So I'm going to say times negative 1 e to the that times 0.02. Not really going to move it much. So this is 6.5 times 10 to the 79 is equal to e to the 1. I'm amazed my calculator can still do this in the register. Once it gets to 100, it'll start breaking. ln both sides. That pulls down something that's not very much smaller. And then we divide by 1.7. And we should get a time that's more than, well, we get 108. So wait, t is equal to 108? Well, that's not good. Because after 110 seconds, it's 50% complete. So it should take more time for it to get to 98%. What do we mess up here? I came from here. If after 110 seconds it's 50% complete, so I said, okay, cool. 50% is 1 minus e to the a, e to the b is e to the a plus b. Oh my god, you're so right. Oh, I'm just tired. Yes, yes. This is a grand mistake.
Surprise, motherfucker.
Oh, I messed up. I did this whole thing wrong. Oh.
What the fuck is this piece of shit?
Okay, I'm gonna call it. I'm too tired. Plus, I'm not feeling too good. I'm getting worse. Okay, cool. All right. Otherwise, when you come back to the stream, I'll help you out with this on our next stream, which would be a Monday. Okay, cool. Let's close it out. All right, thank you everyone for coming to office hours today. Had a fun time working with all you guys. Appreciate all the questions. Appreciate learning some fun stuff in material science today. All the fun math things I went with you guys as well. You guys are awesome. Big shout out to everyone else keeping my math straight, I would say. Thanks, boss man. Yeah, you're a good dude. Okay. Have a good night. Yes, thanks. We're gonna go raid. I love this guy. Science and was it? It's Ask a Gamer something. Let me see who he has on his stream right now. Particle physics. Yeah, we're gonna go raid this guy for sure. So this is a cool stream. It's based out of University of Florida. It's this guy. He's a professor, and he gets other professors to answer questions while they play video games together. He does it on Wednesdays. So yeah, let's go say hi to him. He's a particle physics guy. Go ask him some cool stuff. Okay, cool. All right, thank you everyone for coming. Enjoy the rest of the week. Enjoy the weekend. Our next stream will be on Monday. That's going to be at 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Central, 6 p.m. Eastern. Come on by, say hi. Enjoy the weekend. We'll see you around. Peace.